Hi everyone! Today we're going to continue talking about centers of triangles. Our objectives for today are that students will be able to identify and use medians and centroids and altitudes and orthocenters in triangles. Let's get started. Alright, first off, we're going to define median. So what is a median? A median is a segment joining a vertex to the midpoint of the opposite side. Alright, so a median is a segment joining a vertex to the midpoint of the opposite side. So for example, in this diagram, we have our vertex up here. Alright, so this would be our vertex of the triangle, and the vertex to the median, or to the midpoint. Alright, that is our median. So anytime we have a segment, so we would say that this segment right here is a median because it joins the vertex to the midpoint of the opposite side. Now, when we're talking about a centroid is the center of a triangle, and that's where all three medians of a triangle intersect. So, the three medians of a triangle intersect at a point called the centroid. So first thing we want to do is identify all the medians. So we know that medians go from the vertex to the midpoint of the opposite side, from the vertex to the midpoint of the opposite side, and from the vertex to the midpoint of the opposite side. So we just highlighted all of our medians, and if we want to list them out, we would say that BF is a median, we would say that CD is a median, and AE is a median. And if we wanted to name the centroid, we know that P, it's a center, is the center. It's just a letter, just a point. All right, and then another key thing to notice is that medians meet at the midpoint of the opposite side. So that means it cuts all the sides in half, right? If F is the midpoint, AF is congruent to FC, and if E is the midpoint, then BE is congruent to CE. So knowing that key characteristic of a centroid is important as well. Also, another special property about medians is about dealing with medians and centroids is that what we need to know is that we can break apart the median into special parts. So, for example, if we're dealing with this median right here, we know that AP is going to be twice as long as PE. So, for example, we would write that AP equals 2 times PE. So, if PE was X, AP would be 2X, if that sort of helps a little bit, okay? We can also say that AP is equal to, or is, 2/3 of AE, if we're looking at the whole segment. So if we're looking at the whole segment of AE, AP, this top half of the median, is 2/3 of the whole thing. And then we can also say if AP is 2/3 of the whole thing, then we know that PE, so the smaller part, is going to be 1/3 of AE of the whole thing. And we can also say that PE is 1/2 of AP, all right, because we know that PE is half of AP if AP is 2 times PE. So these are key characteristics about medians and centroids. All right, so practice, and example number 1, first thing we want to do is read through what we're given and mark up our diagram. Then we're going to find each missing measure. So if we're given that P is the centroid of JKL, and JK is 22, so we know that this distance right here is 22, and KN is 13, and OL is 18. So first things first, we know that the median, so if LM is the median, that means M is the midpoint, so JM is congruent to MK. And if JN is the median, N is the midpoint, so KN is congruent to NL. And if KO is a median, then O is the midpoint, and JO is congruent to OL. So if OL is 18, JO is 18. And that's one piece of information we needed to know. If KN is 13, then NL is 13. And that's another piece of information we needed to know. And if JK is 22, that means the whole thing is 22, and if M is the midpoint, that means JM is 11 and MK is 11. So MK or KM is 11. We needed to know that. And we needed to know, let's see, what else? Does that solve anything else? Let's see, what else can we figure out? If we needed to know KL, KL is this whole distance, and we know that each is 13, so this has to be 26. And last but not least, let's see, oops, I wrote that in the wrong spot. KL is 26. And then JL is this whole thing right here, and we know each is 18, so this is 36. So JL is 36. And we just found all the missing measures we needed to know. All right, in number 3. In number 3, we're given that G is the centroid. So that means that CF is a median, AD is a median, and EB is a median. That means this is a midpoint, midpoint, midpoint. So we can mark that up accordingly. Then we also know that AG is 8. All right, so we're given that AG right here is 8. We're given that GF is 7. And we're given that BG is 5. So BG is 5. That's right, this distance right here. Then we want to find each missing measure. So we need to use what we know about medians when they intersect at a centroid. So let's start with GD. If we're looking for GD, that's this distance right here. And we know this is the smaller piece of our median. So we know that GD is going to be half of AG, or it's going to be 1/3 of the whole thing. So half of AG, half of 8 would be 4. So therefore GD is 4. Then if we're looking for AD, we know that AG is 8, GD is 4, so add them together. The whole thing is 12. Next, we're looking for CG. So we're looking for this distance right here. Now we're given that GF is 7, all right, and we know that CG is going to be twice the length of GF, or we know that GF is half of CG. So if we multiply 7 by 2, we get 14. So that means that CG is 14. Then we want to know GE. So we're looking for GE, that's this distance right here. And we know that BG is 5, and we know that GE is twice the length of BG. So GE has to be 10. And then BE is just the whole thing. So 5 plus 10 gives us 15. And we're done. All right, number 5, we're given that J is the centroid of DEF, and then we're given lots of different lengths. So first off, we're given that DH is 51, so that's this whole thing right here is going to be 51. We're also given that GF is 60, so this whole thing, did a bad job of drawing that, this whole distance is 60. And we're given that EI is 57, so this whole thing is 57, and we want to find each missing measure. Now, when you're given the whole median, in order to find the two parts, so the bigger part and the smaller part, what you would do is you would divide the median by 3. So what we would do is we would say 57 divided by 3. What does that equal? Now, 57 divided by 3 equals 19. So we know that GI is 1/3 of the median. So GI is 19, and EJ is 2/3 of the whole median. So 19 times 2 gives us 38. So EJ is going to be 38. Now, in order to find each part of GF, we would say 60 divided by 3. We want to break it up into thirds. That's 20. So GJ is 1/3 of the whole median, so it's just 20. And JF is 2/3, so 20 times 2 is 40. And then last but not least, if we know DH is 51, if we divide that by 3, we get 17. So we know that JH is the smaller part, that's 1/3, so that's going to be 17. and DJ is going to be 2/3 of the whole median, so that's 34. Now we found each of those individual parts, and then we want to identify which part is which. So DJ, we found out that's 34. JH, we figured out was 17. Then GJ, we figured out to be 20. JF is 40. And then EJ we figured out to be 38. And JI is 19. All right, if you have any questions on that, call me over so I can help you. Otherwise, let's keep going. All right, so I want you guys to try number 7 on your own. Remember, read through your given information, identify what you know about this triangle and what does it mean to be given all these lengths, and then identify each missing measure. So go ahead and give this one a try. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. All right, so here's the answers to number 7. Now, how did we find them all? So first thing we want to do is identify that if G is the centroid, all of these are medians. Okay, so BF is a median, AE is a median, and CD is a median. And if we know BF is 72, if we divide that by 3, divide it into thirds, each third is 24. So we know GF is 1/3, so that's 24. And BG is going to be 2/3 of the whole median, so that's 48. That's how we get BG and GF. Then we're also given that AC is 64. So AC is this whole side, and the whole thing is 64. Now, BF is a median. That means F is the midpoint of AC. So it cuts this whole side in half. So each of these is 32. So that's how we get AF is 32 and FC is 32. And then last but not least, we're given that GE is 27. So if GE is 27, that's 1/3 of the whole median. If we double that, we get AG. So AG is 54. And then if we add 54 plus 27 together, we get the whole median. We get AE is 81. All right, if you have any questions on this, be sure to call me over. Otherwise, let's keep going. All right, so just for time's sake, we're going to skip number 9 because it's so similar to number 7. If you understood number 7, you could easily do number 9, all right? If you want to quickly pause your video right now, I will give you the answers in a second so you can try this one on your own, and then I'll put the answers up, but I'm not going to go through it because it's so similar to number 7. So if you want to give this one a try, go ahead and pause your video now. Everybody else, let me just quickly write down the answers. So for those of you who did try this one on your own, you paused it and tried it, you should have gotten that HE is 11, EF is 25, HF is 28, DE is 25, and CH 14, BE 33. All right, so if you didn't try this one, that's okay because it's so similar to number 7. If you did, there's the answers to number 9. All right, so we're going to keep moving forward. All right, now we're going to be talking about altitudes and orthocenter. So first of all, what is an altitude? An altitude is a segment joining a vertex to the opposite side so that it is perpendicular to that side. All right, so an altitude is a segment joining a vertex to the opposite side so that it's perpendicular to that side. So looking at this example, we've got our vertex up here. All right, this is our vertex, this point. And the segment that's joining it to the opposite side so that now it's perpendicular. So this segment, the altitude, has to be perpendicular to the other side. It's not necessarily at the midpoint, it's not necessarily a bisector, but it has to be perpendicular. All right, now altitudes can be inside a triangle, outside of a triangle, or on the side of a triangle. So for example, if it's inside of the triangle, it could look like this. All right, so we go from the vertex to where it would make it perpendicular, and it would be right there. So this right here would be our altitude, and that would be, let's call it A. That's our altitude. Now, if you have an obtuse triangle that looks like this, so that first was an acute triangle, right? If we have an obtuse triangle like this, it could be on the outside. So it's just wherever it makes it perpendicular. So for example, our altitude would be this distance right here. That would be A, because it's going from the vertex of the triangle to the side and making it perpendicular. And then last but not least, if it's a right triangle, where it would be perpendicular would be the actual side, the leg of the right triangle. So this would be your altitude. Okay, so if you have any questions on this, please feel free to call me over. Otherwise, let's talk about the orthocenter. All right, so orthocenter. The three altitudes of a triangle all intersect at a point called the orthocenter. So using our diagram on the left, we want to answer some questions. We want to name all the altitudes. So if we're looking at here, we know P is our orthocenter, and from the vertex to where it would be perpendicular, so BF would be an altitude. C from the vertex to D, that would be another altitude, and A to E would be another altitude. So if we're listing out all the altitudes, we would say BF is an altitude, AE is an altitude, and CD is an altitude. And our orthocenter would be P. Now, there's not a lot of special characteristics about altitudes and orthocenter, so they're probably one of the more basic centers of triangles that we've talked about so far. So just the key characteristics are that it's always perpendicular to the side. So the altitude is always perpendicular to the opposite side. That's the most key characteristic about altitudes. And we know all the altitudes meet or intersect at the orthocenter. All right, so now we've officially learned about all the different types of segments within triangles and triangle centers. So we're just going to complete the following sentences to review some vocabulary that we've learned. So first of all, the three perpendicular bisectors of the sides of the triangle all intersect at the circumcenter. All right, so it's important to remember that circumcenter is dealing with the perpendicular bisectors. Then when we're talking about incenter, we're talking about the angle bisectors. So the three angle bisectors of the angles of a triangle all intersect at the incenter. Then when we're talking about the centroid, we're talking about the three medians. So the three medians of a triangle intersect at the centroid. When we're talking about the orthocenter, we're talking about the altitudes. So all the altitudes of a triangle intersect at the orthocenter. Then it's important to know that a circumcenter is equidistant from the vertices of a triangle, and an incenter is equidistant from the sides of a triangle. All right, so quick review. The three perpendicular bisectors intersect at the circumcenter. Three angle bisectors intersect at the incenter. Three medians intersect at the centroid. Three altitudes intersect at the orthocenter. So we've talked about circumcenter, incenter, centroid, and orthocenter. Those are the four centers of triangles that we've talked about. Also important to remember that the circumcenter is equidistant from the vertices and the incenter is equidistant from the sides. All right, so I hope you learned a thing or two about medians and centroids, altitudes and orthocenters, and I've gotten a nice little review of all of our centers of triangles today. If you have any questions, please call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day. Bye.